Okay, this is going to be a video lesson on graphing the rationals. We've worked on some of the components. Now we're going to sort of put it all together. So the first thing we're going to do is we're going to find the vertical asymptote, which if you solve the denominator, it's x equals 4. The situation we have in this case is the denominator is bigger, so my horizontal is y equals 0. So I'm going to go ahead and plot that. Y equals 0, x equals 4. Okay, now I'm going to go ahead and I don't have any holes. Okay, x-intercepts. So the idea is I got 0 equals 1 over x minus 4. If I cross multiply that, that would be 0 equals 1, which means I don't have any. Okay, y-intercept, I'm going to substitute 0 for x. So that's 0 minus 4, which is 1 over negative 4, which is negative 1/4. Okay, all right, so y equals negative 1/4. Okay, all right. Now to finish the graph, what I want to do, I sort of know that there's going to be a curve here. I want to check where is the other one. So what I want to do is I want to put, like, let's say put 5 in here. Okay, all right. So 5 minus 4, okay, would be 1. 1 over 1 would be 1. So 5, 1. Okay, so it'd be a point here. So what I got is I got a graph going this way, and then a graph going this way, approaches the asymptotes. Okay, the domain, okay, all right, x is an element of all real numbers, such that x can't be two things. X can't be the vertical asymptote or the whole, so that's 4. The range, okay, y is an element of all real numbers, such that y can't be, that can't be the horizontal asymptote, which is 0. Or the y coordinate of the whole. So for the domain, the idea is x is an element of all numbers, except x can't be the vertical asymptote, x can't be the x coordinate of the whole. And for the y is an element of all such that y can't be the horizontal asymptote or the y coordinate of the whole. Okay. All right, so that's the idea. Now I discontinuities here. I just have a vertical asymptote, which is called an infinite discontinuity at x equals 4 in this case. Okay? All right? Let's go on to another one. All right, vertical asymptote. Solve the denominator, it's x equals negative 5. I have a tie situation, so I divide those. That's going to be y equals 3. So y equals 3, x equals negative 5. Okay, I do not have any holes because I did not eliminate anything. For my x-intercept, 0 equals 3x minus 2 over x plus 5. Cross multiply that, that's going to be 0 equals 3x minus 2. I would add 2 over to the other side, and then I would divide by 3. So x equals 2/3. Okay, so I'm going to have something right here. Okay, for the y-intercept, x equals 2/3. For the y-intercept, I want to put 0 in for x. So basically that's going to be 0 minus 2. Put a 0 in there, 0 plus 5. So that's negative 2 over 5, which is negative 2/5, which is right here. Okay. So as you can see, I got a curve down in that area. So it's going to be somewhere here. Okay, I didn't draw that very well. Going through those points. If you want to find more points, you can always put in more. But you'll pretty much know that. So what I want to do is put in negative 6 into that. So 3 times negative 6 minus 2. Okay. And then negative 6 plus 5. That's going to be negative 18 minus 2 would be negative 20. Divided by negative 1, which would be 20. Okay. So that's going to be all the way up here. So what does that mean? I'm going to have something that does this. It's in this area. Okay. The domain, all right, is x is such that x it can't be negative 5. The range, y is an element of all real numbers such that y can't be 3. My discontinuities, I have a vertical asymptote, which is an infinite discontinuity at x equals negative 5. Okay? All right, let's go on to another example. All right, so this one, my vertical asymptote, I solved that as negative 6. I have the situation where I have that extra number out there. That's going to be y equals 3. Okay, so I got this I got negative 6. Okay. I have no holes, none. My x-intercept, I have 0 equals 1 over x plus 6 plus 3. I would subtract the 3 here, so I get negative 3 equals 1 over x plus 6. I cross multiply that up, so it's negative 3 times x plus 6 equals 1. That's negative 3x minus 18 equals 1. Add 18. That's negative 3x equals 19. And divide by negative 3. Okay, 19 divided by negative 3 is negative 6.3 repeating. So x equals negative 6.3. Okay, so that is going to be here. All right. My y-intercept, I put 0 in for x. So that's 1/6 plus 3, so that's 3 and 1/6. All right, so I got 3 and 1/6. All right, so I sort of know where those are, okay? All right, if you want to find another point, you could. I could put negative 5 in there. That's 1 over 1, which is 1. 1 plus 3 would be 4. So if I put negative 5, that's negative 5 over 4 up, so that's here. So we know that this is going to do this action. Okay, if I want to put negative 7 in, okay, that would be 1, negative 7 plus 6 plus 3. So that'd be 1 over negative 1, which is negative 1. Negative 1 plus 3 is 2. So that's negative 7, 2. So negative 7 over 2 up. Whoops, right here. So what that would be is something that look like this. Okay, all right. In my domain, x is an element of all our numbers, such that x can't be negative 6. My range, y is an element of all numbers, such that y can't be 3. My discontinuities is I have a vertical asymptote, which is an infinite discontinuity at x equals negative 6. Okay, all right. So pause your video and go ahead and work on those. Make that it's a negative 6 there. Okay, so now we're going to move into some of the whole stuff. Okay, so what I want to do, okay, is I want to factor. So what happens is this is x minus 5. If I factor that, that's going to be x minus 3 and x minus 5. Okay, I eliminate that. That's 1 over x minus 3. Now, what I eliminated becomes x equals, and I got a hole at that solution. Okay, all right. Now, I'm going to tell you how we're going to graph that in a second. What scenario do I have now? I'm going to solve the denominator. That's x equals 3. I have the horizontal being y equals 0 because the denominator has a bigger power. Okay, so 3. Whoops, that's terrible. Hold on. 3 and 0. Okay, all right. All right, now I want to graph the whole of the graph. Now what you want to do is put that number in, which is 5, in for the x value into this part there. So 5 over 2, which is 1/2. So 5 over 1/2. I put a little open circle there. Okay, all right, my x-intercept, I want to solve what's remaining. So 1 over x minus 3, cross multiply that, that'd be 0 equals 1. So I'm not going to have an x-intercept. That's going to be none. My y-intercept, I'm going to put 0 in for x. So that's 0, 1 over negative 3, which is negative 1/3. So that's here. So I sort of already know what that's going to be. Now what I could do is I could always put into this function, I could put 4, and then the other side of that would be 2. So if I put 4 in there, 4 minus 3 would be 1. 1 over, so I put in 4, I would get 4 over 1. So 4 over 1 up. So I know that that's going to be there to go through that hole. Okay. I know it's going to be down here. If I put 2 in there, that's going to be, the result would be 2 minus 3, which would be negative 1. So 1 over negative 1 is negative 1. So 2 over negative 1 down. So I sort of know that this is what's going on. Okay. So when I graphed, my y-intercept was at negative 1/3. My domain was all real numbers except x can't be can't be 3, can't be 5. I should actually write it like this. 3 and 5. The range is y is an element of all real numbers such that y can't be 0. And then also, when I found the whole, it was at 1/2, so it can't be that. So my discontinuities, I have a vertical asymptote, which is an infinite discontinuity at x equals 3. I've got a removable discontinuity, which is the whole at x equals 5. So you have two different discontinuities there. Okay, let's go on to this one. Okay, if I factor in the interest of time, if I factor this to be 3x, x minus 3, x plus 1. On the bottom here, this is x plus 3, x minus 3. This gets crossed off. Okay, so my whole will be at x equals 3. Okay, my vertical asymptote, if I solve the denominator, is x equals -3. All right, the scenario I would have is the tie. So 3 divided by 1 would also be 3. So I got -3, +3. Okay, if I want to evaluate where the whole is, I would put in 3 to what's remaining. So 3 times 3 plus 1 up top, and then 3 plus 3. Okay, so that's going to be 9 plus 1, which is 10. 10 divided by 6. So 10 divided by 6 is 1.6. So 3 over 1, 2, 1, 2, 3, 1.6 up. So that's right there. Okay, that 1.6 will be important. For the x-intercept, I would set the y equal to 0. Cross multiply, that's 0 equals 3x plus 1. That'd be -1 equals 3x, divide by 3. I get x equals -1/3. So right here, okay. The y-intercept, I put 0 in for x, so that's going to go away. That's 0 plus 1, 0 plus 3, so that's going to be 1/3, okay. So I got an x-intercept of x equals -1/3. I've got a positive intercept of 1/3. Okay, I can clearly see I've got enough points here to clearly graph this. Okay, all right. Now, if I want to figure out what that's going to be, I'm going to take -4 and put that in. So that's going to be -12 plus 1, which is -11. -4 plus 3, which would be -1. That's going to be all the way up to +11. So that's way up here. Okay, so I know this is what's going on there. Okay, so my domain is an element of all real numbers such that x can't be -3, x can't be 3. You can write it like that as well. My range is y is an element of all real numbers such that y can't be 3 and also 1.6. Okay, my discontinuities, I have an infinite discontinuity, which is the vertical asymptote at x equals -3. I have a removable, which is the whole at x equals 3. All right. All right, so what I would want to do here is I want to take out the x. That's going to be x plus 3. I want to take out the x here. That's going to be x squared minus 2x minus 8. So basically what happens here is I have x over x plus 3 over x. If I factor, that would be x minus 4, x plus 2. Okay, my x's would cross off. Okay, so that whole would be at x equals 0. All right, and so what I have remaining, I'm going to go ahead, because I ran out of room. I've got x plus 3 over x minus 4, x plus 2. Okay, oops. All right, so now, if you look at this, I have two vertical asymptotes. I have a vertical asymptote at 4, and I have a vertical asymptote at -2. All right, the scenario I have is the denominator happens to be bigger, so my horizontal one will be at y equals 0. So y equals 0, x equals -2, x equals 4. Okay, all right. My x-intercept, okay, I put 0 equals x plus 3 over x minus 4, x plus 2. I cross multiply that up, that's 0 equals x plus 3. Solve for x, I get x equals negative 3. So my x-intercept's at negative 3. Now someone would say, Mr. Evans, the horizontal asymptote, it can't cross that. It actually can. It's just going to approach that value, and I'm gonna get into how that works in a second. Okay, so that's x equals negative 3. Okay, my y-intercept, I put 0 in for x, so that's 0 plus 3 over 0 minus 4 times 0 plus 2. So that'd be 3 over negative 4 times 2. So that's going to be 3 over negative 8. Okay? So 3, that'd be 0, negative right there. Okay? All right? So y equals negative 3/8. All right? Now, we want to plot some other things on here. So I'm going to take a look at, well, if I were to put, my whole of 0, if I put that in for x, I get the same thing as the y-intercept. So that sort of overrules that. Okay? All right? So that whole is going to be right there at 0. Sort of a weird coincidence. Okay? Now, what I want to do is I want to figure out what is that going to be at negative 3. So if I put negative 3 into here, that'd be 0. Okay? All right, I already got that point. If I want to put negative, let's do one more, negative 4, that'd be negative 1, that'd be negative 8, and that would be negative 2. That'd be negative 1 over 16. Okay, so it actually does this. Okay, so what happens is the graph actually goes like that. It crosses over, but then reapproaches. All right, if you put negative 1 in here, okay, and do some calculations, all right, you got 2. You put negative 1 in there, that's going to be negative 5. Put negative 1 in there, that's going to be 1. That's going to be negative 2/5. So it's going to be here. Then if I put another 1 in there, let's say 1. If I put 1 in there, that's going to be 4. That's going to be negative 3. That is going to be 3. That's going to be negative 4/9. So what's going to happen here is that this part is going to be like a U shape. Okay, and approach that. Okay, all right. And then if I put 5 in there, that'd be 8. Okay, 1 and 7. So that's 8, 7. So like 1.1 something. Okay, so here is my other one, and this one's going to level off. It's not going to cross the x-axis. Okay. So, what's my domain? X is an element of all real numbers such that x can't be 4, x can't be negative 2, x can't be 0. And then my range is y is an element of all real numbers such that y can't be 0, y can't be negative 3/8 because that's where the hole was. My discontinuity, I have an infinite discontinuity at x equals 4, x equals negative 2. I have a removable discontinuity at x equals 0. Okay. All right. And then you guys can go ahead and try those on your page and just keep working those. All right. If you need to plot points, but basically your graphs are approaching those horizontal asymptotes.